Okay, so this video is on lesson 6-1, and it's the first part of the lesson, so this is lesson A. Your goal is to be able to create a sample space and to know what an outcome is and events and figure out total possibilities for that particular situation, okay? So let's look at our definitions for the lesson. So we're going to talk about probability. And probability always has a varying outcome. And if you look on the back of your notes, you don't have to do it right now, but probability is in between 0 and 1. 0 means it's definitely not going to happen, and 1 means it definitely will happen. It's going to be in between those two numbers, okay? When you talk about probability, you need to know the difference between an outcome and an event, okay? I like to think of an event as something that you're doing, okay? So let's say that you are rolling a die. So the event is you actually rolling that die. The outcomes are the actual possibilities of you rolling that die, okay? What if you flipped a coin? So you flipping a coin would be a single event. The outcomes of you flipping a coin would be heads and tails, okay? If you had a spinner that had 10 different numbers on that spinner, and you spinning the spinner is the event, and the outcomes would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the difference between the event and the outcome. The sample space would be all of the outcomes of that particular situation. So the situation could have one event, or it could have 3 events. I don't know, but we're going to talk about the differences between all of these, okay? Now, there's also a little thing in here that says that you can use braces. If you want to write your sample set, it's called set notation. But I just kind of like box the sample space in. All right, so here we have an example. It is straight out of your book. This right here on the right, that's called a tree diagram. When I make my tree diagrams, I always go left to right. And I don't know why, but your book went like vertical. And it drove me nuts. So I went and I found online the sample space for this particular thing. So I'm just going to warn you, if you look in your textbook, it's going to look different, but this one makes more sense, okay? So let's talk about the situation. So the situation is that you flip a coin and then you roll a 6-sided die. How many events is that? So event number 1, you flip a coin. So we're going to go over here and we're going to highlight that. And we're going to label that event 1. This is really, really basic, foundational. You've got to understand how to write these events and all of your outcomes, okay? So event number 1 is flipping a coin. And then it says over here, you also roll a 6-sided die. So that is my second event, event 2. Now, if you look underneath coin, it actually lists the outcomes. So the outcomes of you flipping a coin would be heads and tails. So underneath heads and tails, what I want you to do is write 2, because you have 2 outcomes for that first event. So you're flipping a coin, you have 2 outcomes. Now, I don't know why your textbook didn't make a big deal of this, but I'm going to make a big deal out of it, okay? Now, the second thing that you did was roll a die, and that die had 6 sides. So for each outcome in your first event, you have to branch it out. That's where that tree diagram comes into play. You have to branch it out. So you have 6 options or outcomes for each outcome in your first event. So you're going to say 2 in your first, but you have 6 in your second event. Since it's each, you're going to multiply. So for those 2 events, you're going to have a 12 total outcomes. You're going to do this every single time, whether you make a tree diagram or not. You've got to think, how many outcomes do I have in each event? And you're going to multiply those together. That's just kind of a basic question. It's actually called the fundamental counting principle, but they don't talk about it in section 6.1, okay? So does anybody have any questions about how this tree diagram works? Have you seen it? Can you nod your head? You see it? Okay, you've seen it before. So what about this right here? This list of all of your outcomes, that is what I mean by sample space. You need to be able to find the sample space regardless of each situation. Okay, so that's what we're going to practice today. Sample space, total outcomes, and then we're going to find theoretical probability. All right, we're going to start out easy, super easy. One 6-sided die is rolled. And if it doesn't tell you how many sides, you're just going to assume it's 6 anyway, okay? How many events is that? Just one event, okay? Don't confuse outcomes with events. So I'm going to have one event. So I'm going to say event 1. That is rolling the die. And we have 6 different outcomes. So that's where we're going to list it. So the listing of each outcome, that's where our sample space comes into play. So I'm going to do 1, 2, 3, 4, 5, and 6. Now, obviously, if it's a different die, if it has 20 sides to it, I'm going to have 20 numbers there, okay? So how many possibilities do I have if I have the one event and I have 6 outcomes? 6 totals, right? So I only have to multiply your outcomes if you have more than one event. So this right here, all of these numbers is the sample space. And if you wanted to, you can list them using braces and just put a comma in between each possibility. All right, let's make it a little bit more challenging. Okay, so our second situation, we're going to spin that spinner. There's a picture of the spinner. And then we're going to flip a coin. So I want you to think, how many different events do I have in that situation? I've got 2. Okay. So I'm going to do event 1. And I'm going to do event 2. Now don't do your tree diagram just yet. Okay. So event 1 is spinning the spinner. And event 2 is flipping the coin. And it really does help, especially when you're new at doing this, to write all of these things out. So event 1 is spinning the spinner. How many different outcomes can I get if I spin the spinner? I have 4 different outcomes. So I'm going to put 4 times. Now event 2 is flipping a coin. How many different possibilities do I have when I flip a coin? 2. So I'm going to have 4. And then I have 2 each for one of those 4. So 4 times 2 gives me 8 total possibilities. So after I do my tree diagram, I should have 8 possibilities in my sample space. If you don't, something happened, it went wrong. Okay, so what are the 4 possibilities for the spinner? Now, when you do your tree diagram, listen carefully. The first event needs to be equally spaced. So I'm going to do 1, 2, 3, 4. Because you're going to have to branch your tree diagram out, you need space. If you don't give yourself space, it's going to be all like jumbled up, okay? For the coin, though, I have 2 possibilities per outcome. So I'm going to have 2 possibilities here, heads and tails. 2 possibilities here, heads and tails. So you're going to have to repeat that every outcome you have in that first event. Heads, tails, heads, and tails. Just try to be as neat as you can. Now, if you've done it correctly, you should have 1, 2, 3, 4, 5, 6, 7, 8. Now, your tree diagram is not your sample space. It helps you write your sample space. So the first thing I'm going to write down for my sample space is 1H. So when I write 2H, that means I spun the spinner. Wait, that shouldn't be 2. That should be 1. So it should be 1T. There we go. Okay, so what that means is that I spun the spinner and I got a 1. And then the first one means I flipped the coin, I got heads. The second one means I flipped the coin, I got tails. So you need to keep going throughout the whole tree diagram. We're going to say 2H, 2T. So I spun the spinner, I got a 2, flipped the coin, got heads. 3H, 3T, 4H, 4T. That is your sample space, not your tree diagram, okay? So this is your sample space. And the reason why we're doing these sample spaces is because in a minute, we're going to be doing probability with that. And later on in the chapter, we're going to be doing conditional probability, all different kinds of probability with this. All right, example number 3, we're going to do 3 coins, which means 3 events. So event 1, event 2, and event 3. Okay. All right, so we're going to do total possibility. So in that first event, I have 2 outcomes, heads or tails. Event number 2, heads or tails. Event number 3, heads or tails. So it's going to be 2 times 2 times 2, which is going to give me a total of 8 total outcomes in my sample space. Now it's the same as the last one, but my tree diagram is going to look different. So event number 1 is going to be heads or tails. See how much space I put between those? I've got 3 events, so I'm going to have to branch it off 3 different times. So for each one of these, I'm going to have to branch it heads and tails. And you're going to have to try to be as neat as you possibly can. So after event 2, I have 4 possibilities. And then event 3, I'm going to multiply that again by 2, which is going to create 8 possibilities. Now that's your tree diagram. Tree diagram is not sample space, so we're going to have to actually write out all of the possibilities. So the easiest way for you to do that is just kind of write for each event in 3, okay? So this is heads, heads, heads. Work backwards. So this is heads, heads, heads. Let me change colors to show you. So this one ends up with tails, right? So that would be tails, heads, heads. So what you have to do is you have to follow that pathway to write exactly what happens on that first toss, second toss, third toss, and just continue throughout. So this one's going to be heads, tails, heads. And this one's going to be heads, tails, tails. So those 4 result from the first coin being heads. That's what that is. So let's go ahead and write out these last 4. Okay, so there's my sample space. Okay, so like I said before, your probability is going to range between 2 numbers. It's going to be impossible at 0, which is 0%, and it will never ever be anything greater than 1, because 1 is 100%. It's definitely going to happen. So probability is going to be somewhere in between those 2 numbers. Probability can be written as a whole number, a fraction, a decimal, or a percent. This is the formula for probability, and it's that same probability that you studied back in middle school. If you're going to highlight anything, I would say highlight favorable, which is what you want to happen. So what they're asking you about, you're going to count how many possibilities there are, and then you're going to divide that by the total number of possibilities. And that's what we've been doing the whole time. We've figured out the total, which is going to be your denominator. This is called theoretical probability, and tomorrow or in the next lesson we're going to talk about experimental probability. I couldn't think of it for a second. Okay, and typically when they write out the probability, they use a big capital P and then parentheses, and then they write down whatever event they want you to measure. Okay, take a second, read that, think in your head how many events that's going to be. So if they are guessing 3 questions, that's going to be 3 events, correct? Okay, so event 1, that's literally question 1, okay? And then you have event 2, that would be question 2. And then event 3 would be question 3. So you have 3 different events. And what we're trying to do is we're trying to figure out if they got it correct or not. They're guessing it. So what's our possibility if we're guessing at a true or false? We only have 2 possibilities, right? Just the 2. So I'm going to have 2 possibilities here times 2 possibilities on the second question times 2 possibilities on the third question. We get, here we go, 8 outcomes again. They're not always 8. Now that's going to be your total outcomes. That's going to be the total in your sample space. So first question, it's either going to be right or wrong. So R for right, a correct guess, and W for a bad guess, which is wrong. So event 2, same, but we have to branch it out. Right and wrong, right and wrong. And event 3, right, wrong, right, wrong, right, wrong, right, wrong. Now imagine doing this question with 5 questions. So you see how your tree diagram is going to get really big really fast. So you got all of, you're just multiplying. Every time you add another event, you're going to have more branches and more branches. So the sample space, you have to write them out. So it'll be R, 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 W, R, W, R, R, W, W. Now that's just the top half. Okay, the bottom half is going to be W, R, R, W, R, W, 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 R, and then W, W, W. So total sample space should have 8. Now we're going to answer the question. So that's what we did on page 1. So the question says, what is the probability of guessing exactly 2? Exactly 2 correct. So we're going to write probability of exactly 2 correct. So what I want you to do is I want you to count how many outcomes have exactly 2. Now it can't be more than 2. It has to be exactly 2. Okay, so I have highlighted the 3 that I found. So right, right, that's 2. Right, wrong, right, that's 2. So I only have 3. Does everybody see that I've got the 3 right here? So the probability is going to be 3 out of the total. How many total do I have? 8. Done. Okay, second one. Have you already done that tree diagram for a 3 coin flip? We've already done that, right? Okay, flip it over on the back. So I'm gonna keep this on the screen, and then you look on the front page of your notes. Okay, find where you did the coin 3 times. Look at that sample space. I want you to go back and I want you to highlight where it says exactly 2 heads. So I'll do that with you. Probability of exactly 2 heads. So where would that be? 2 here. 2, 2. Do you see anything else that has exactly 2 heads? No. So how many do I have? Okay, they got 3 out of 8. 3 out of 8. Okay, this isn't on your notes, but I want you to do this one. What's the probability of 3 tails? So just pause it, look at your notes, and see if you can figure it out. So if I look, I only have 1 outcome that has all 3 tails, but you got to say out of a total of 8. Okay, so since it's February, we're going to talk about snow. So there might be a snow possibility tonight. So I'm going to tell you and I'm just making this up. Y'all don't get your hopes up. So the probability of y'all going to school tomorrow, I'm just going to say that that is 0.8 or 80%. That would be school, right? Okay. So could you figure out the probability of not going to school? Yeah, it's 20%. How'd you do that so fast? What'd you do? Subtract it from? Yeah, and we've done that a lot with like DK, okay? So in statistics, it's typically Q. Now that's not mentioned in your notes for Algebra 2, but it is Q. So the complement would be 1 minus 0.8, which is 0.2 or 20%. So you can actually do the complement in your head. So the complement is actually the opposite of what they're asking you for. So let's go over here for a second. Right here is a sample space of you rolling a 6-sided die twice. So your first roll would be the white, and your second roll would be the red. Y'all with me? You got 6 possibilities times another 6 possibilities would be a total of 36. Let's write that down. 6 times 6 gives us 36 possibilities. We did not have to do a sample space for that. Thank goodness. Okay, so I got a total of 36. So if they ask us about the probability, am I going to use 36? Absolutely. Okay. So question 1 says, what is the probability that the sum, so you would be adding the 2 together, is not 6? Now, I just want you to scan that for a second. Don't count it. How many? There's going to be a lot that are not 6. Y'all agree with me? Like there's a lot that's not 6. So what I'm going to do is I'm going to do the opposite instead. I'm going to find the complement. But how am I going to write that out? So if it says the probability of the sum is not 6, I'm going to say 1 minus the probability of the opposite of that. So if it's not 6, what's the opposite? Sum is 6. You see? See the difference? So it would just be everything else. Now what I want you to do, and I actually really want you to do it, I want you to find how many of these 36 add up to 6. Okay, I'm going to pause the video. I want you to count how many of these add up to 6. Trust me, it's better this way than the other way. Okay, so it looks like I've got 1, 2, 3, 4, 5. 5 out of how many? 36. 5 out of 36 add up to be 6. But I'm looking for the ones that don't. Right? So what's 1 minus that? So if 5 add up to be 6, then how many don't? 31 out of 36. The probability is going to be 31 out of 36. So instead of you counting 31 different pairs, you can use the complement and you can do the opposite. Okay? So I want you to do the same thing on this one. Now, a lot of my students so far, they've gotten this wrong. So I want you to look at this. I want you to tell me if this is right or if this is wrong. So the complement of this would be the sum is greater than or equal to 9. So y'all tell me, is that right or is that wrong? What do you think? Okay, this means less than or equal to 9, correct? Is that everything else? What do we need to do to change it? Yes. Okay, see, equal to is already included, so the complement can't include anything here. So you have to make everything greater than 9. So it has to be everything else. Everything else. So really quickly, let's find the ones that have a sum greater than 9. So 1, 2, 3, 4, 5, 6. Everything else adds up to be 9 or less. Okay, so if I'm going to use the complement, I know that 6 of these are not what we're looking for, right? So if 6 of them are not what I'm looking for, how many am I looking for? 30 out of 36. And you could just use your calculator to simplify that or to change it to a percent. All right, so that's it. And then on your homework, we're going to mark out number 4 because I don't like that question. And that leaves you with 7 examples. And we are done. Just let me know if you have any questions.